This problem is two-sum. I'm going to be doing it in JavaScript. So it says, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. They give you a few examples. So with the first example, we have an input array with the elements 2, 7, 11, and 15, and the target is 9. Of course, we get an output array of 0 and 1 because these are the indices we would have to add to get to the target. In a second example, we have a array with the elements 2, 3, 2, and 4, and the target is 6. So of course we get an output array of 1 and 2 because we're going to have to add the indices 1 and 2 to get to the target 6. And in example 3, we have an input array of 3 and 3, and the target is 6. And of course the output is 0 and 1 because you can't use the same element twice. And yeah, these are the indices in which we would need to add to get to the target. We have a list of constraints. So the length of our nums array is greater than or equal to 2, but less than or equal to 10,000. Nums of I, or the values inside of our array, are going to be greater than or equal to negative a billion, but less than or equal to a billion. And our target is going to be greater than or equal to negative a billion and less than or equal to a billion. And only one valid answer exists. We're trying to see if you can come up with an algorithm that is less than O of n squared time complexity. Okay, so with the two approaches I'm going to show you, the first approach, the brute force approach, it has a runtime complexity of O of n squared because we're going to have to use a nested for loop. So that's what's going to give us that O of n squared time complexity. And with the second approach, we're going to use a map. So since we're only using one for loop, we have a O of n time complexity. Now that would be a solution that they would be looking for as far as this one algorithm that is less than O of n squared time complexity. But as far as space complexity, with the brute force approach, you have a O of 1 space complexity because we're not going to have to allocate any memory or any variable amount of memory, I should say, because the only memory we're going to have to set aside is the memory for our return array. So the array with the solution or the indices to our solution. Now, with a map, however, since we're going to have to allocate a variable number of memory or a variable amount of memory, why do I keep saying variable number? Since we're going to have to allocate a variable amount of memory, that has a space complexity of O of n. Because depending on however many elements we need to add to the map increases in size and whatnot, and all of that good stuff. So what we're going to do as far as the brute force approach is we're going to start with a base number. So in this case 2, and we're going to add every number to the base number. So 7 to 2, 11 to 2, and 15 to 2. And if we don't come up with a solution, then we're going to move on to 7, and 7 is going to be the base number. Then we're going to move, or then we're going to add 11 to 7, then 15 to 7, and then if we don't get it, then of course go on to 11 and so on and so forth. Now in this case, of course, we get it on the first iteration because 2 plus 7 is 9, but that was just if we didn't get the target when we first tried this or when we, first ran this algorithm. So what we're going to do now is actually build the algorithm, or I'm going to actually code it out for you. So with the brute force approach, I'm going to let I equal 0. I is less than the length of our nums array, I plus plus, and then of course we're going to need another for loop equals to I plus 1. J is less than the length of our nums array as well, and then J plus plus. And then we're going to see if nums of I plus nums of j is equal to our target. And if it is, then we're going to return a new array with the values of I and j. So our indices pretty much. So let me go over here, put a little space here, make sure this is right, and then I'm going to run the code. We shouldn't get any errors. Hopefully we don't. It's accepted. And now I'm going to submit this. And runtime 213 milliseconds, faster than 14.32%. So as you can see, this is what's going to give us that O of n squared runtime complexity. And as far as space, the only thing we're going to have to worry about allocating memory for is this return array. So this is going to be a O of 1 operation as far as this an O and N, an O of N, and this as well an O of N. Now I'm going to show you using a map. So I'm going to delete this and then I'm going to make the map. So let's map equal new map, and then I'm going to have our for loop that we're going to use to iterate over the elements. So let's I equals 0, I is less than the length of our nums array, and then we're going to increment I, and then we're going to get the complement. The complement is pretty much the number that we need to add to nums of I in order to get to the target. So let's say nums of I was 2 in this case. Target was 9. 9 minus 2 would give us 7. So 7 would be the complement. And what we're going to do is we're going to look in the map to see if we have the complement. Because remember, the lookup, insertion, and deletion of items in a map is a constant time operation. So that is what's going to help us find things faster as compared to when we used the brute force approach and we had to iterate over every element in order to try to find our target sum. So what I'm going to do now is I'm going to check to see if the map has the complement. And if it does, then I'm going to return a new int array. Sorry, I'm thinking about Java. And I'm going to get the complement, and I'm also going to get the current index. Now, what just happened here was I'm going to return a new array with the value of our indices. When we store items in a map, they're stored in key value pairs, if you didn't know. And since it's an unordered collection, we can't reference things based off their index how we usually would, or how we would usually do in an array. So what we're going to have to do is we're going to have to get the value. So let's just say 2 in this case. We're going to have to get 2 and assign it to whatever index it is. So we're going to have to set 2 as the key and the value would be 0. So that way we have a way, so that way we, yeah, that way we have a way of referencing the index that we're located on in the array. So if we don't have the complement, what we're going to do is we're going to have to add it or set it, I should say. So nums of I to I. All right. So I'm going to run this, and then I'm going to go over it again just in case someone didn't understand. Hopefully this works right, and would hurry up and compliments. Oh, why do I keep thinking of Java? Okay, let's Java, C Sharp, both of them. Map dot has compliments. Why is this not working? Let complement. Oh, okay. Well, I need to put this inside of the for loop. I don't know how I got outside, but yeah. So put this here. Move this back a little. So about right there. Well, not this line here. Okay, and now this should work. It didn't even tab over. So accepted, and then we're going to submit this. And as you can see, 102 milliseconds faster than 61.05%. So we have to use about zero point 0.9 more megabytes of memory here, but the runtime was significantly a lot less than when we used the brute force approach. So I'm going to run this again to see how much memory we use this time. Because remember, we have to allocate memory for however many elements we put in the map. So what, 70 milliseconds, 43.4 megabytes. Yeah, so as you can see, we use more memory here. That means we had to add more elements to the map. Okay, so that was pretty much it for this. I'm going to go over it a little bit more. So let's say we have our map here. And the solution we were looking for, we're gonna use this as an example. The solution we were looking for, the target we're looking for is 26. So 15 plus 11 is 26. So 26 is going to be the target, and we're going to start off with 2. 26 minus 2 is 24. We're going to look to see if we have 24. Do we have 24? Well, no, because we just started and we have nothing in the map. So what we're going to do is we're going to set nums of I, so 2, to whatever index we're on. So since we're on 0, we're going to set 2 to 0. And then long story short, we're going to do this until we get to the end. So 2 is going to be 0. 7 is going to be 1. 11 is going to be 2. And when we get to 15, what's going to happen is the target is going to be 26. 26 minus 15 is 11. So we're going to check the map to see if we have 11. We do have 11. It's an index 2. So what we're going to do is we're going to plug 2 in here and the current index we're on. So 3, because 0, 1, 2, 3. 3 is where 15 will be located. So here, if the test case or if the target was to be 26, then we would have the indices of 2 and 3, or we would return the indices of 2 and 3 here, and we would set them here, I should say. All right.